In this video, we are going to see the behavior of IO intensive task with the increase of threads. We are going to use the code of file write data file. Let me explain the code to you. In this file, the task, this is basically the producer is putting the task. Let me go to task which is being done in this code. Okay, so this task is basically creating the file handle file objects, and it is using buffer output stream. Then for each of the counter, the load is taken from the map, and here intentionally CPU intensive task is commented so that we will be seeing mainly the IO operation, and is getting the string which is written into the file. Once the complete load is written to the file, we do the plus so that the data is written to the file. Here the number of strings which we will be writing will depend on the chunk size which we set from the command line. So this is basically mainly IO work. One important thing which I want to highlight here, that in this method the file handle or file object, handle to file object, we are creating per thread wise. The reason for this is when parallel write is happening, and instead if we give only if we use the same file handle or object, then in the parallel write we'll get wrong entries. In a sense, when one line is being written, at the same time other thread will write, so you will see two lines being written in one line, and that too will be some portion of some portion from first thread, and then suddenly one line from the second thread, and then the remaining line up from the first thread. So parallel write will not be thread safe, and you will get undesired result. Hence we need to create its own file handle in the task which is running in different threads. So this way the writes of one line will be happening one by one after the another. Order will still be different, but that is fine. Here we're assuming order is not important. Okay, now let's move to the demonstration which I'm going to explain, which we are going to have a demo. Now in this IO task, what we will be doing, that we will first change the buffer size. So this will highlight the impact, what happens with the change in buffer. Then we'll keep that as a constant, and in second try we'll change the chunk. Each thread is having each thread is taking the load from from the buckets, and each bucket is loaded with some fixed amount of load in a list. So that is the chunk size. So we will change that also. Basically that correlates the amount of data we flush when we're running uh, parallel writes. So this will give us the optimum value of buffer and chunk, and once we know this, then we'll go to our main measurement task, that is change by seeing the behavior by changing the threads. Now let me explain the command line arguments. Command line arguments is in the Java file, and then the first argument is the load. We'll be going with the load of around 10 million. Then threads, how many threads? So initially for A and B we'll be going with 1 or 2 threads, and then the chunk, we'll be changing the chunk, and this argument is basically fixed, as I explained in the previous video. This is to control that producers first finishes producing the load, then only consumer will start. And the last parameter is buffer size. This is what this is one of the important parameters for case A. We will change this and we'll see the behavior. Yeah. Before we go to the demo, I'll just explain the result which we have seen, and then we will see the demo also. This is first run and 2 runs for case A. I'm talking about case A. Now here what I have done, that this is around 10 million record in one thread. Initially I kept the chunk size constant and changing the buffer size. Let me bring out the point. Yeah, so this is the value I gave, and this is this next one. And by changing the buffer size, see the difference of execution time. It's very huge, so it's important to note this. And now let's see and I will also do the demo. So this is for effect of changing buffer. So it's very important to have a right buffer setting. Generally 10,000 is optimal. Beyond 10,000 we will see there will be no changes or deterioration. Now next one is the sample which I have already executed, and I will show the actual demo. But before that, to explain the concept, which basically what we are going to run. This is buffer size which will keep constant. This is run number 1, this is run number 1, this is run number 2, and this is run number 3. So here chunk size I have increased. So if this is a chunk size, if we increase the chunk size, the execution time has improved, but not drastically, but at least we know if we increase the chunk size, improving the execution time. And now if I increase the thread compared to previous runs, then the execution times looks much better. Of course it is because of the thread. So chunk does have an impact, hence I kept the chunk size fixed as 10,000, and the buffer also 10,000. Okay, so now we'll go to the demo part. Code is seen, so I'll just close the code. Okay, preparing for the demo. This is the command line. This is our CPU uses. Okay, CPU disk, this much is the main parameter which we see today. Okay, now we will go with the case A, which was case A where buffer change. So we will see that the load is 10 million. We have one thread, and initially we go with chunk size 100. This is constant, it's a flag, and here we will see was with 1000. Now it is executing. So it is completing 13.9 seconds. Now here I will increase the buffer size to 10,000, and so they started execution. What we are going to see total time. See, the total time has reduced to 9.9 seconds. So you observe that this is very important to use the buffer size. Just for the sake of demonstration, I will change it a little bit more to see the impact of increasing the buffer size. Okay, here we do see a little bit more improvement. So we can take 11,000, and SSD usage has also improved. So we can take this value, or we can try it to even higher value. Okay, so around 11th we see this time getting higher, so we can consider close to 10,000. Basically this one was with chunks buffer size as 11,000, but we can consider, okay, we can take 11,000 or 10,000, but for my experiment we'll go ahead with the 10,000 as a buffer size. Okay, so we have seen the effect of buffer changes. Now we'll see changing the chunk size. Let me clear the screen. Okay, and now basically I'll keep the buffer size as 10,000, and we increase the chunk size. first let me go with chunk size of 100 also. This chunk size basically is affecting the event when we do the first. So here it looks 9.1 and this is what we got. Now let's see whether we can have better performance if we increase the chunk size. Yes, it has better performance, so it's a good idea to increase the chunk size, and SSD usage is also going high. What I'll do, I will increase it to 10,000 because it's running in one thread. And the buffer is also 10,000. So if I try with this 10,000 as the chunk size, yeah, it has an improvement. So for one thread 10,000 looks good, but let's see for the sake of experiment how it behaves by increasing the chunk size. Good. So execution time is improving with the chunk size, so you can keep experimenting by increasing more chunk size. We saw SSD is going higher, so more SSD was happening and it was doing better. Okay, here also now I have increased chunk size to 20. So we see that increasing chunk size, it does improve the performance. Okay, thank you, and I will see you in the next video where we will keep the buffer size and chunk constant, and we will start increasing the threads.